That's good. It's almost like apathy. Do not disturb his mirror. What could possibly go wrong if it wasn't?
Yeah. You want to full screen share slides so people know they're in the right room?
Yeah.
Hello, beautiful people.
Is Barbara okay to do the minutes, did you check?
Oh, Mr.
Some people who haven't read my email, but why I'm so Matthew Bush yesterday made a comment about why do you see the problem? So I can't read the next time.
That's like they have a little conference at St. James.
No, it's there. They haven't understood. People that place back
We have a medium-sized pink box this time.
Right. Yeah, so I see it here. People direct off of it, and then when they come up to 10 minutes later, they'll be doing it.
Okay, we'll start in a couple of minutes.
I'm from the Nordics, always 2 S's. So it's a little bit.
Yeah, I'll start passing around the blue sheets after the chair slides, so have a chance to pick up people who show up late.
Do you want to talk through them, or should I?
If you want to drive.
Much to- Okay, so welcome. This is DNSSD. Hopefully everyone's in the right room. I'm Tim Chown, co-chair with David Shinazi here, and Skinazi, sorry. So we've got 2.5 hours and a fairly full agenda. We'll show you that in a moment. First of all, please take note of the note well. It has updated recently, so if you're at the back, I guess the fighter pilots will be able to read that, but the note well is also linked from the meeting pages as well, so you should always read it to make sure nothing's changed between meetings. We have a minute taker. Thank you very much, Barbara. I would encourage others in the room to help Barbara. You can go to the Etherpad there and make any additions or tweaks to things you said, maybe to clarify any points or to get your name spelt correctly. That's always tricky when the minute taker can't see your name badge. And we also have the professional Jabber scribe, Mikhail, sat there doing the Jabber function for us. Thank you very much, Mikhail. So just the basic working group info. This is the same as it's always been. If you want to find out more information about the group, those are the places to go to, and how to join the mailing list if you're not on it already. In terms of the document statuses, we have 2 RFCs that have been published now. We have the one on the consistency of labels between conventional DNS and DNS-based SD, and we have the original requirements RFC. The working group items that we have that we're progressing, there's the DNSSD hybrid proxy, which has since been renamed the discovery proxy. That's been updated after review by the ISG, so Stuart will tell us a little bit more about that shortly. We have a couple of, we have in fact 3 privacy-related drafts that have been authored. Those are currently parked while we review the scope of the privacy work we want to do. So we've got a reasonable amount of time today to discuss that, and Christian and Stuart have a few slides to stimulate some discussion on that later in the agenda. DNSSD push, again, that's been updated very recently, and Stuart will include that in his talk. There is also the DNS stateful operations draft, which is required by push, which in turn feeds into the discovery proxy. That's, though, being progressed in DNSOP. Some of you may have been in DNSOP earlier in the week. Stuart presented on that, and there were no objections raised in the room, which was good, but Stuart again will update us on that here. So we're hopeful that that will progress and push and the discovery proxy with it. Whether we advance them at this time or not is a question for the group to discuss later. So the goals for this session is, first of all, just to understand any remaining issues with that little triple of drafts. I think we're in a good position. We want to progress work on the discovery DNSSD discovery relay, which Ted will talk about. We want to get an update on progress on the work that's going on over in core in terms of the mapping between the core resource directory and DNSSD. So Kerry is going to present remotely on that. We have a small number of essentially parked documents in that they haven't been updated for a meeting or two. So we'll just run through those and check where we are with them and what's happening. And then we've got, I think, about an hour in the agenda to discuss the scope of the privacy work, agree some requirements, and agree as a group what we're going to progress. So as I said, we have Daniel and Christian have produced those other 3 privacy-related drafts. They're quite well advanced. I think the group generally thinks it's good work. The question is that the right work? I think we just want to just step back for a moment and just look at the bigger picture briefly before we progress. Okay, that's what we'll be doing today. And in more detail, here's the agenda again. So if it's actually reduced to quite a small font. So we'll start with Stuart giving an update on the DNS stateful operations and on the update on push and the discovery proxy. We've then got Ted talking about both the discovery relay and the simple HomeNet naming and SD architecture. We've then got Kerry coming in to talk about Core RD DNSSD mapping, and then we'll end up with the privacy discussion. So I will attempt to cut over to Stuart's slides. There's a remote thingy there, which hopefully will do the business. This one. Oh, okay. Okay.
Okay, thanks, Tim. So we'll start by talking about DNS stateful operations. Quick recap for those of you who don't remember the history. We started off with DNS push notifications to support the discovery proxy. And Ray Bellis wisely pointed out that we're really conflating session management with the specific behavior of push. And that did slow things down a little bit, but that was a good observation. And we've been working together on what started off being called session signaling late last year. I think a lot of people finally understood that it was not just about managing session timeouts for TCP connections for DNS. And it got a new name, Stateful Operations. So just to cover the recent history, in draft 04 last September, that was when the name changed. We also had a lot of debate about whether every request must have a corresponding response. And we decided that that was not a requirement. And that was good because that simplified the push notifications document. And that's one of the things that was holding up the push document is we needed to wait to see what the consensus was on DSO before we could really move forwards. We had a bunch of feedback at IETF 100. We addressed that, updated it this January. The DNSOP working group chairs started the last call in February. That completed. We got lots of good feedback. If you look at RFC diff, you will see that we changed quite a lot in the draft, but nothing material about the protocol over the air. That was submitted before this IETF meeting, so DNSOP could review it and confirm that all their issues had been addressed. We had some more feedback from Paul, and that was addressed this week because we wanted to stay on top of this and not delay anymore. So we believe it's now ready for IETF last call. We presented this same information at the DNSOP working group and didn't get any objection to that. So I'm hoping the chairs will decide that this is now ready to move along, which is important because you can see there are these three other documents right now that are depending on it. So diving into these documents, push notifications was critically depending on DSO because that was what it was based on. In the new DSO draft that doesn't require replies, that actually simplified a bunch of text in the push notifications document. There was some very awkward text about some replies that really didn't carry any information. And the text was saying that the R code had to be 0. And if the R code wasn't 0, then what you had to do about it. And all of this was describing stuff that should never happen. So it was much simpler now that we can just delete those pages. The draft actually shrank by 6 pages, which almost never happens when I work on a draft. Tom and I also updated the iterative algorithm for discovering which server to talk to. So that will need some review. I see Andrew sitting at the back there. So hopefully we've got some text now that satisfies Andrew. And if there's still more to change, maybe Andrew, you, I, and Tom can get together to bash that and make sure we're all happy with it. Discovery Relay was also updated this week. Ted will be talking more about that. And the Discovery Proxy draft was also updated to address the feedback we got from the IESG. We actually got lots of really good feedback from the IESG, and it gave me a lot of faith in the IETF process that we have smart people in the leadership who had some really thoughtful comments, and there was not a lot of duplication, actually. All the different IESG members had different areas that they suggested. So textually, there's quite a lot of change to the document to address that. I added a diagram because somebody wanted a picture showing what the network layout looks like. There was a request for an example of how this actually works in practice. Rather than put that in this document, I added that as an appendix to the roadmap document and put a reference here to the roadmap. So if people want a bit of a real world example to make it tangible, they can look for it there. And as always happens in IESG review, we had some more wording for the security consideration section. The roadmap is not currently a working group document. That is something that the working group can decide. What I added this week is the walkthrough. This is some text I previously sent in email when people have asked me, so how does this work in practice? How does the device know what domain names to query? How does it discover what server to send those queries to? So I like to use the example of the terminal room here at the IETF meetings, because you can actually follow along in a terminal window doing the same commands yourself and see for yourself exactly how it works. So that is the document update.
Okay, thanks, Stuart. So just running through the three things, well, three main things there are the DSO. Are there any comments on the DNS stateful operations? Obviously, it's a DNS op item. There were no comments raised there. I think as a working group, I believe we can't influence anything, but we can certainly support the DNS op working group in saying that we believe it should go up. So I think that's what we're going to do. No objections here. We'll hear a little bit more from Ted about the discovery relay. In terms of the DNS push, are there any further comments on that? I think, again, we're generally in a happy place. I saw a thumb at the back from Andrew there.
Let the minutes record we had a thumbs up from Andrew.
Just clarify what type of thumb it was. It was a thumbs up. And then the discovery proxy, formerly the hybrid proxy. Any comments on that? Otherwise, I believe we're ready to push up on that. Okay. I mean, I think that I remember. I think the interesting question is, once those three documents are all at the point where they're advancing towards publication, is there any other reason why we'd hold them up? How are we, for example, in terms of implementation experience? Is that something where we might want to just hold off a little bit until we get more of that? Or are we happy to let the IETF process happen?
Ted and I are actually working full-time now on getting that implementation experience. Okay. So I think it is important that we do that so that we don't find some silly mistake and then end up with errata listed on the document. I'm not expecting that to take very long. Okay. Certainly in the next couple of months before the next IETF meeting. In fact, I think we should plan on having code running at the hackathon to show people.
And I think the way the IETF process works, I can't see any of them actually going to publication before the next meeting. So by the time we do the last calls and the ISG reviews, etc. So I think that's going to sit quite nicely. The other question I've got, is there anyone else in the room that's implementing other than Stuart and Ted? Okay, good.
Tom.
Oh, yes. And Tom. Anyone else? Anyone know of anyone else implementing? Okay, that's interesting. So I think it's going to be good that we get...
Oh, well, I should answer your question.
Sure.
There is a team at Cisco that I've been working with who have an implementation too.
Okay.
Oh, and yes, Marcus Stenberg had an implementation of an earlier version of the draft. It would need to be updated, but that's in OpenWRT.
Okay, good. And then I think the final thing coming from, thanks very much. The final thing coming out there was Stuart's updated the roadmap document. I think personally, I think it's a really useful document for the working group. It's showing essentially all the components of the things that we're working on, how they relate to each other, and the sort of direction forward for the working group. And I think adding an appendix showing how things actually work with a practical example, maybe over time, one or two more appendices may be added with other examples like that. That would be good. So I think it would be a good thing for the working group to adopt. Whether we actually ever aim to publish it in the end or not is another question. But I think we should have a decision now as to whether we adopt it as a working group item. So could we take a hum? All those in favour of adopting the roadmap document as a DNSSD working
Actually,
group item?
can I ask a question first?
Sure.
How many people have read the roadmap document? Okay.
That's good. So yeah, the minutes there show that about 8 to 10 hands went up, I think. So all those in favour of adopting the, oh, sorry, got a question first from Tom.
I was going to say, if we reference it in the hybrid, in the discovery proxy, doesn't it have to be published? No?
No. I mean, ideally, yes, but in practice, no.
If it's a normative reference, it would have to be. As an informative reference, we can either leave it as a reference to the draft, or we could remove it when it's time to publish, but that doesn't hold anything up.
Yeah, good question, though. Okay, so all those in favour of adopting this, the roadmap as a working group item? Hum? Very musical. Anyone object? Hum? So note that there was a healthy hum in favour, and I couldn't hear a single hum against. So we'll obviously take that to the list as usual, but subject to that, we can republish as a working group item. Okay, well, thanks very much, Stuart. So I think it's Ted next. So discovery relay first, I think, Ted.
Don't do that. You've got it on play.
I thought I hit pause.
No, oh, I see. Yeah, sorry. You're right. Okay, so here to talk about the discovery relay. What is it? So it's a simple, lightweight relay that can be added to any router. The idea is that it's like a DHCP relay. Very small, lightweight, doesn't need to be changed when features are added to the protocol. It acts as a virtual interface for discovery proxies off-link. So if you have a discovery proxy on a fairly, smart machine that's got plenty of CPU, it can be using this discovery relay that's sitting in your perhaps much less capable router somewhere else, and so it's doing all the work, and the discovery relay is just relaying. It's not. There's no intelligence to it. This idea, I'm kind of starting from the beginning because I'm not sure how many people have actually got this on their radar. But this idea came out when I was working on the HomeNet naming architecture, because we needed a way to separate out the sort of simple HomeNet use case from the more general HomeNet use case. And but actually, the HomeNet use case isn't really the main use case for this. It actually kind of makes sense to have this in pretty much any router that you'd have a DHCP relay agent in. And so it kind of makes sense actually on larger networks, corporate networks, and that kind of environment. So anywhere essentially where a relay agent would make sense. So the benefits of this, it's really simple to configure. You do need to configure it with some authentication information so that you're not just letting any old person connect and start snooping on your MDNS traffic. But you don't need to tell it what the domain names of the link are, or anything that might be changing a lot. So once you've got it set up, it should be pretty easy to just leave it there and have it work. It's pretty lightweight. It does require TLS, but at this point, I think requiring TLS is pretty much table stakes, and so I'm not counting that as making it heavyweight. There are some pretty lightweight TLS implementations that could be used if you have a very small router. And as I said earlier, you don't need to update it when you add features to the MDNS, to the discovery relay. So it essentially allows you to really centralize your network. You can have leaf networks that don't have a lot of intelligence on them, and then centralize everything. And it provides a way also to monitor MDNS traffic on a link. If you, for network management purposes, you might want to see what devices are out there advertising services, and you can just connect to the relay using proper authentication and get that information. Status. So the document actually is pretty complete. I think that if you wanted to implement a discovery relay right now, you could just use the document as written and it would work. I had actually originally a pretty elaborate management section, which was more than half of the document. And I decided that that was a little too elaborate, and so I took it out. I think there was some interesting stuff in there, but it wasn't really about the discovery relay. It was more about the HomeNet use case. So I might take that and put it in a different document later, but it doesn't really belong in a DNSSD document. The document relies on DNS stateful operations, as Stuart said. And as Stuart mentioned, I actually did an implementation of the relay for the Singapore hackathon when I was still working for Nominum. That's Nominum code, so that's been abandoned. But we're working on a new implementation now, and it's not done yet, but it'll be done relatively soon, I think. And Stuart's got a discovery proxy that can talk to it, which is, of course, the other half. And it would be nice to get some working group review on this. I don't think I've gotten a ton of feedback on it. Have you? Yeah, no. So it'd be great if some people could read the document. And so that brings us to the next step, which is that we'd like to request adoption for this document. We'd like to get some review and comments, and if somebody is interested in implementing it, that would be awesome. As Stuart said, we're planning on being in Montreal at the hackathon with working code to test. So if you've got code, we'll be able to test with you. And I'm also planning on stuffing some of this stuff into OpenWRT so that people can just download it and try it out. And it'd be nice to get more router vendors who are interested in this. So that's pretty much it. Any questions?
So hands up who has read the draft? Not necessarily the latest one. Okay, so that's a small number. So yes, we certainly could do with more people reading it and giving feedback. Are there a couple of people that it's not a huge document? Are there a couple of people that might volunteer to have a read and send some feedback to the list? Anyone prepared to do that? Yep, thanks, Barbara. One other, maybe? Don't be shy.
So I'm going to... It's loud. It's a pretty short document.
Yeah.
So it's not a big request.
No.
And I think the other reason we haven't got a lot of feedback on it is because it's pretty straightforward. And I want to give Ted credit for this idea. He listed me as co-author, but I think with Ted's background in DHCP, it was a very natural and obvious thing to Ted that you have this very simple code like a BootP relay agent, which is very stable. It doesn't change. You implement it once, and BootP has pretty much not changed for 30 years. And you can still innovate on the DHCP server. And once Ted pointed that out to me, I thought that was obviously a good idea. I mentioned earlier we've been working with a group at Cisco. That's the group that works on a Cisco product called the Cisco Network Registrar, which is an appliance that runs in the data center. And I was always happy that they were spending their time reviewing the documents for us and doing implementations. But it never felt like a perfect fit because the discovery proxy in my mind was something that lives in the routers and the Wi-Fi access points.
Yeah.
But still, I was appreciative of their time and their input and their assistance in developing this. And then the irony is that it all paid off in the end, because with Ted's idea of having the relays, suddenly the Cisco Network Registrar product becomes a perfect place to implement an intelligent discovery proxy that is using these relays as its tentacles out on every little link in the enterprise or university campus network. So it's funny sometimes how these things come full circle. And when you read the draft, when I read what Ted proposed, I was just sort of nodding, going, oh yeah, that makes sense. There's nothing really controversial there. So that may be why we've not got a lot of feedback, because it just seems obviously the right thing to do.
Yeah, I mean, as Ted said, though, you did have to tweak the spec a little bit as a result of doing the hackathon. So it's not completely trivial, but yeah, a little bit of review would be good.
Yeah, it's good.
Sorry, Mikhail?
Michael Abrams, I had to press enter here for to say I'm the one speaking. It's hard to be Jabber Scribe and be at the mic at the same time. So do you know what version of OpenWRT you're going to be doing the work against?
The head of the tree. I mean, I don't see any reason why it couldn't be backported to an actual release, but my interest is just in getting an OpenWRT that builds. But yeah, I mean, there's nothing in this that is in any way. I mean, when you see OpenWRT advancing, most of the advances are actually hardware stuff and sort of integration stuff. And so integrating this into like Chaos Calma or something like that would be quite easy.
Right, because it is a lot easier if you take something that is stable from an operating point of view and then just create a new feed and see so people can install it from there. Because otherwise, getting people to try whatever's trunk all the time, then they might have other breakage. I would like you to take the latest stable and do the work against that, so you don't have a moving target for the rest of the distribution, if possible.
Okay, that's great feedback. It didn't occur to me to do that, but you're right.
Good. Okay, thank you. So we should take a view as a working group as to whether we want to adopt this item. I mean, from everything we've heard, it seems a very natural idea that fits with the model that we have. So are there any further questions before we take that decision? Does anyone need to know any further information to help them with it? No? Okay, so all those in favor of adopting the discovery relay as a working group item, please hum now. And any opposition or anyone think it's not a good idea? So again, note that as a healthy hum in favor and none against, and we'll take that one to the list.
Thank you. Why do you have a giant red button on the desk?
But is our big red button bigger than the other big red buttons? We're going to have to bring Kerry in remotely later, so it's probably to do with that.
Okay.
This one.
So the next topic is simple HomeNet naming, and I just wanted to present this to the group. I think I presented this to the group maybe once before, but just trying to raise some awareness about what's going on there. So HomeNet is using DNSSD discovery proxy as the basis for the simple naming architecture. And there's some push in the HomeNet working group, largely from me, to use the registration protocol as well, but that's not in simple naming. So I'm actually, my goal is actually to do the simple naming document and also an additional advanced naming document that layers on top of the simple naming document. And so the goal is to actually implement that unicast solution that we get out of the registration protocol. Why does anybody in this room care? Well, I think the advanced HomeNet naming architecture really kind of hits a lot of use cases that we care about, I think, or at least is relevant to them. It's possible that what we have in the simple naming architecture would not be just a drop-in thing that you could use in a corporate environment, a small organization. It might not be a drop-in thing that you could use in a number of the use cases that we've talked about, like the EDUCAUSE use case. But we don't actually really have a management story for DNSSD right now. And so I think that even if the HomeNet naming architecture itself is not what we wind up using to address that usability issue in other environments, it's probably going to be very relevant to that work. So I think it's worth looking at for folks in this group. So what's going on with that? I looked over I hadn't worked on the simple HomeNet naming architecture document in about 6 or 7 months. And I guess I did a small haircut for it for Singapore, but I looked at it about a week or two before the deadline, and realized that the organization was just terrible. So I don't know. It was kind of ad hoc when I wrote it down. It was a stream of consciousness. So having that break really helped, and I reorganized the document. Still needs a lot of work. Basically, I've got a nice skeleton for it now, but it needs more detail. And so it's not ready to publish yet, but I'm really hoping to have something that looks like a final version of the document by the next IETF. It currently depends on the discovery relay. Advanced HomeNet naming will depend on the registration protocol. I haven't actually done a ton of work on advanced HomeNet naming, but there was a HomeNet naming architecture document that preceded the simple HomeNet naming architecture document that has a fair amount of that stuff in it. In fact, you know, some of the ideas that turned into the registration protocol were mentioned in there. Let's see. So the ask for the DNSSD working group, well, we already talked about several of these documents. Basically, I'd like to get all of these documents adopted because I need them for HomeNet. We already talked about it. We already had a hum for Discovery Relay, so we don't need to go over that again. It'd be nice to. We didn't talk about the registration protocol?
No, not yet.
Yeah, it'd be nice to get that adopted as well, because I think that's the nice thing about the registration protocol is that it basically lets us have a migration path to a network where we're not using multicast for every service discovery. You know, we still have multicast as a fallback, so we still have compatibility with old devices, but this allows us to do things like, you know, some devices like IoT devices that are running on lossy, low-power networks may not actually have access to multicast. And so right now, you either have to have some kind of shim in place to make them look like they're doing multicast, in which case, what does that shim look like? Or you could have them do a unicast registration, but we need a protocol for that. And so this is a protocol for that. So let's see. So I would say that right now it's not the right time to read the simple HomeNet naming architecture, but I'm going to send out a new version of it, hopefully fairly soon. And when that comes out, I'm going to announce it on the DNSSD mailing list, and I'd really appreciate it if folks here could take a look at it and send any comments that they have. You know, so in particular, like what's missing, and does this seem like it has relevance to the DNSSD management problem that you know, that makes it relevant to this working group as well. So, questions, comments, tomatoes?
Okay, thanks, Ted. So just a reminder, this draft is a HomeNet working group item already, or at least the simple HomeNet naming architecture document is. So I think there's a couple of perhaps if we go back to the slide with all the draft names on.
That's this one.
Yeah. So we've obviously already taken a decision on the relay. I think there's a broader question with the service registration and what's implied there in terms on the group's feeling of a move towards supporting unicast here and moving as far away as we can from using multicast in new work. So I think it'd be useful, maybe we've got plenty of time today just to hear some thoughts on that. So there's kind of two implicit things here with the service registration. One is the unicast and multicast position. The other is essentially returning to the DNS update type of model. And, you know.
Yeah, it's a little different.
Yeah, I know, but it's having the working group understand what's different this time and why it will be likely to be more widely adopted. So we've got a little bit of time if people want to talk to those two topics.
Stuart Cheshire from Apple for the notes. I wanted to expand a little bit on something Ted mentioned, talking about Internet of Things. Home automation and devices like that are increasingly becoming very popular. Apple has the HomeKit line. Nest has the thermostats. There are a bunch of these things. OCF is working on standards there. The Zigbee organization is doing it. The Thread Group, which is an organization started by Nest and Google, is working on low power, low speed, short range wireless networks where you need a mesh to cover the whole house. And when you have a mesh, it gets really hard to do multicast. And when you've got battery powered devices, that want to save power, running the battery down, forwarding multicasts for other devices is also not good. So for me personally, this is an area that I think is important and something that I'm going to be working on. If there's energy in this working group to help design that future non-multicast discovery protocol, then that would be great, because the more input we have, the better. But regardless, it is something that we're going to need for the new technologies that are coming out.
Yeah, and I think there is another draft elsewhere with Charlie Perkins and some other people involved in terms of describing the issues with multicast. I've forgotten the specific name of it, but I think that's the rationale for a push here towards remaining compatible with the existing multicast things that are out there, but in new work, trying to lean towards more use of multicast.
Yeah, I think the draft from Charlie Perkins is about Wi-Fi.
But it's yeah, I guess
right.
the principle, maybe that's a suggestion for Charlie.
Which is also true. I mean, I was talking about the mesh stuff, but even Wi-Fi, now we're up to gigabit speeds for unicast, and multicast is 100 times slower. So we don't even need to look at things as esoteric as mesh networks to see that multicast is running out of steam.
Yeah. Another thing to say about the registration protocol, by the way, is that it also adds some, not huge amount, but some security, which is not present in MDNS. In MDNS, basically anybody can blab on the network, "My name is Foo," and what happens if somebody else had already claimed Foo is that whoever it was that already claimed Foo is like, "Oh, I'm so sorry," and gives up Foo. And so it's very easy to attack services on the network by just claiming a name. And one of the neat things about the registration protocol is that it actually uses public key cryptography to assert ownership over a name that hasn't yet been claimed, and that makes it impossible for somebody who doesn't have the private key to then claim that they own that name. So
you've described that in the service registration protocol.
That's in the document. Yeah. Now you could in principle do that with multicast too, but it seems like there's no reason to do both. So yeah, that's a nice feature, and I think probably equally as valid a motivating feature as the multicast issue.
Michael Abramson again. Yeah, I was in MBOND the other day where Perkins he was presenting that, and I brought up this issue in 2015 or something, that this is something that should be worked on, and I still think that today the IEEE, for instance, and the IETF has not decided, like, okay, this is how we're going to solve it. It's going to be a little bit of both. But I think that if that draft at least describes some of the physics limitations and so on, and what you want to do on radios generally. So it's not only Wi-Fi, even though it's focused on Wi-Fi.
Well, and there's also obviously lots of shenanigans in mapping multicast to actually unicast at the lower layer, and all sorts of other things that could happen.
Right, but yeah, I think the takeaway from that is that yes, we should move away from multicast because it has downsides on those kind of medias.
Which, and the implicit question then is the coexistence of what we have today with MDNS and DNSSD alongside whatever new thing is, and to make sure that those aren't going to interfere with each other in some way or another.
Yeah, Stuart might be able to speak to that more authoritatively than I can, but
you're making a good point. We'll have some cases where the old and the new coexist. We may have other scenarios like the thread mesh network, where the old multicast stuff is just never present from the start. And I think that's another reason we want to push ahead with developing this, because there are other things going on in the industry that could really use this. And if we don't have a solution ready, they're going to have to invent something different. And then that makes things
awesome as our stuff.
It will not be as awesome as our stuff. That's right, Ted.
Yeah, I mean, maybe there's an opportunity for an AD to make a comment here. We haven't, I was just saying to David, we haven't recharted for a long time, if at all. I think we've tweaked our milestones a bit. So it may be appropriate to look at our charter, which does mention things like mesh networking and maybe review the charter and include that more explicitly in our future work plan. Does that make sense?
Terry Manderson, snoozing AD. Yeah, look, I'm happy to have a charter discussion at any time. I think this working group is one of the working groups in the IETF that is insanely responsible, and I'm very keen to listen to the members within this working group as to steps going forward.
Oh, so why am I giving you
One thing I'd like to add is I think we're doing more and more work in the privacy field, and that's not reflected at all in the charter. So I think we might be useful to change it to reflect that.
Michael Abramson, yeah, and I think when I brought up the multicast issues on radios, there were a lot of people there was 3 or 4 different working groups that deal with radio, like 6LoWPAN and money and something else. So we need to make sure that we're not stepping on someone else and that we're using whatever experience and protocols they might already have. Just in this case, we're not reinventing the wheel, because they had a lot of, I mean, they came out and said, yeah, of course it's like this. Why didn't you know? And most people in the IETF didn't know. So there's a lot of knowledge that might be untapped as well.
Yeah, well, we've also seen in the past couple of meetings, and we're going to hear today, that Core and Anima are doing their own service discovery things in different contexts as well.
Michael, if you could send a link to Charlie Perkins' document to the list, I think that would be educational for all of us.
Yeah. Tom
Brewster-Terry, speaking about milestone in the charter, the dates need tweaked again.
Yes, we didn't look at that. No, nor was there a slide on that. Yes. Yes, that will be something to discuss when we do a charter. So I think, again, just speaking to David, I don't think we want to hold up this work that Ted's listed there, the service registration in particular, and essentially the unicast work. So we don't do anything to preclude that progressing quickly. But it does sound like refreshing our charter would be a good idea. So that's probably something we can take to the list, discuss what sort of things should be added, what maybe can come out now that we've either done the work or we don't believe it's any, relevant anymore. And I think maybe even looking back to the original, for example, the original EduCause request that led to us partly led to us doing this work, and see whether we think we've met what they were asking for would be an interesting thing when we're looking at the charter. So I think we'll take the charter to the list. In terms of adopting the service registration thing, I haven't asked David about that at the moment. I think we would like the work to continue. How many people have read that? I suspect we don't have many people that have read it yet, which is an issue. What do you think, Ted?
Oh, I thought it was great. Wow, that's loud.
Well, David, what do you? Yeah.
Sorry.
About adopting, is it a bit early to adopt service registration from what we know so far? I think if we push ahead with the charter where we clearly say we want to do the work, then that's implicitly going to lead to an adoption for it.
Get a few more. Maybe we should take names.
Yeah.
It would, no, sorry,
I think a bit more review would be required.
I was about to say the same thing. I think when not enough people have read it, it's too early. It's not useful to ask for adoption. I think as part of the discussion about changes to the charter, that's a good opportunity for us to figure out what are the things we want to work on, what current drafts cover those areas, and then we can actually give people a reading list of things to look at, and then we can have a meaningful discussion about it.
Yeah, that sounds good.
So on the topic of EduCause, I didn't really want to get too deeply into that in the DNSSD presentation because it's sort of tangential. But yeah, I had heard the term the EduCause petition passed around a lot, and I thought, oh wow, that must have been like edu, so it must be like really detailed. And no, it was like a half a paragraph of we want Apple TV to work on all of our networks. That was pretty much
what it boiled down to.
Yeah, that's what. No, that's what they said. That's literally what they said. But if you actually turn that into like what are the requirements, then obviously one of the requirements is an enabling technology to allow the service, the announcement of service availability to be reachable from around the network.
Yeah.
And the other is some way to operate that machinery so that it either is automatic, or if not automatic, then at least pretty easy to operate. And I think that DNSSD has addressed the machinery that you need to do this part of the problem pretty well at this point. I think there's more stuff we could do, and as I've said, but the discovery proxy pretty much solves the transport aspect of the EDUCAUSE request. What it doesn't solve is how do we deploy this. So, and how do we deploy this is, well, you just put it on all of your things and it just sort of works, right? Except no. If you look at how you would have to, I mean, this is something that we had to think about in the HomeNet because we have to automate the deployment, right? There's no way to have the end user set it up, whereas in an educational environment, maybe we could have the IT people do it. So it's not that hard to set up, but it might be worth actually having a document about that. And it might make sense to have a DNSSD document about that. I'm not proposing that at the present, but it's something we should probably be thinking about. And if we're chartering, then make sure that.
I think it's something we have discussed in the past. I know Tom had, for example, a draft that never got published about actually deploying what we're doing in an enterprise. And I know Ralph spoke to that topic 2 or 3 meetings ago. So I think putting that stuff together, I think what you're doing with the HomeNet stuff is kind of addressing that question in the HomeNet area, but for a campus or enterprise, having some equivalent viewpoint or document there
Yang
would be
models.
Good. Yang, thank you. Okay. So I think the agreement there was to so the simple HomeNet. So yeah, the agreement was to work up an updated charter, and out of that we will better understand the work that needs to be done in that area. And I think the same will apply to the privacy, which David mentioned as well. The privacy isn't really mentioned much in the charter at the moment. And out of that, then we'll understand which documents we need to adopt and which gaps we have for work we need to do. Okay, so I think that covers that off. So I think the next thing on the agenda is Kerry. Kerry, can you hear us? The chairs, of course, can't see. There. We can see. Are you there, Kerry? I don't know if we have to press the red button. All right, yeah. So Kerry, join the queue and just pretend you're answering a question, but actually present. So we don't get to press the red button.
We do.
We do.
Join the queue and then we press the red button.
I don't think you've done this before. If you use, it can be your first red button. I think there's just a sort of an arm raised button, isn't there, or icon you press just to basically ask a question. In Meet Echo, there should be, I'm assuming you can hear us, there should be a little, I think it's a raised hand icon or something you press to say you want to ask a question. And I think it's that.
All right.
That,
can you hear me?
Aha. We see the Kerry Pac-Man, it's moving.
Super.
Yay, we got you,
Right.
Kerry. The slides though, hang on. Probably best if I bring the slides up here locally and then you. Hang on just a
Yeah,
second.
let's start here. Yep. So I'm Kerry Lynn. I'm presenting on behalf
Okay,
of my other
we're up
co-authors
on
listed
slide
here.
1, so just tell us when you.
The problem space that we're discussing is machine-to-machine or thing-to-thing discovery. This is apropos of the earlier conversation about rechartering and DNSSD. There's nothing specifically in our charter that says we need to cover this domain, but there is a charter item in the core charter that says that their resource directory must interoperate with DNSSD. So that's why we're here, hopefully to get some help from folks who are in DNSSD and may have use cases to contribute. The history of this draft was that it started life as an individual draft. I did this with Zach Shelby several years ago. It was incorporated into the resource directory draft, but then it was split out to basically eliminate dependencies that the RD might have on other work that was still immature. Resource directory draft is being teed up now for working group last call. I think one thing we want to do is to gain some more implementation and operational experience before we go to working group last call. But this work. No. Yeah, right.
Sorry, Kerry, just a moment, Kerry. We're not advancing slides here. Just to confirm, I just wasn't sure whether you might be advancing them locally in the thinking or not. So, if you can you actually see which?
But I just wanted
from Mitaco, can you see the slide that we're displaying? Which is
this has been split out from the resource directory draft.
Sorry,
but
Kerry,
it's still a working group item in core, and so we're basically resocializing the topic both in core and here. So now you can go to the next slide. So the use cases that we envision, basically there's an obvious use case at the edge of heterogeneous networks where we might have cross proxies that translate HTTP client requests into CoAP server requests and vice versa. There may be other cases where we've got resourceful clients that are talking to constrained servers, and resourceful clients are quite happy operating with DNS. Also, I think we're talking about supporting hierarchical discovery in very, very large deployments, large buildings with building automation, for example, where you might have tens or even hundreds of thousands of points, where one could use DNSSD for coarse grain discovery and then drill down into resource discovery for even finer grained discovery. And also we expect that it probably covers some chicken and egg cases, like how do you discover the resource directory in the first place? All right, I guess we can go to the next slide. So for those who don't have background with core, it's the kind of the main application protocol developed by IETF for IoT. The main deliverable of core was CoAP, which is the Constrained Application Protocol. It's basically, in its initial state, was REST on top of UDP. The implication there is that requests can be multicast, so it supports something a little bit like MDNS. However, multicast is even more problematic in mesh networks than it is in Wi-Fi, as we've discussed. But for the purposes of examples that I'll bring up here, we could just imagine that we could multicast for resources on the constrained networks. Other bindings are being worked on right now. Specifically, CoAP is being bound to TLS and/or WebSockets for transport over the internet. If there's anybody who still doesn't know what REST is, it's essentially a set of architectural constraints. The world consists of clients and servers, and this thing can be either, is called a servient. That's a term that's been coined. The methods that are available to operate on resources are rather limited to the CRUD, create, read, update, and delete patterns, but also CoAP supports an observe pattern. I think there's a rough equivalence between resources and objects. They both have behavior, state, and identity, albeit resources have a more constrained set of methods that can work on them, as I said. Finally, REST supports, or a very mature REST design for an API should support something called hypertext as the engine of application state. What that means in practice is that hypertext controls, the things that control or change resources are actually links and the methods that act on those links. Next slide, please. So originally Core was not chartered to do their own discovery protocol, but ultimately it became very compelling to use CoAP to do discovery as well as everything else that it does. So Zach Shelby developed this thing called Core Link Format based on web linking. Essentially, it's a way of describing links between a target, between a source link and other target links. So, for example, if you're processing a list, you might have a link that tells you how to get to other members, or the front or the back of that list. If it's a device, you might have a link that tells you how to turn it on and off. You can access the behavior or the links of any device by doing a get to /wellknown/core. You can optionally include a query string, and you'll receive back a collection of typed links that basically tell you how to control that device. So the web linking draft defined a set of target attributes for these links, such as resource type, the interface description, and the size that you get back if you were to do requests on that. Now, resource directory is essentially a way of capturing all of the state for a given constrained network into a directory so that you don't have to do multicasting. You can still unicast to individual devices, but it's a bit like, capturing all this into a DNS directory. Next slide. So in our draft, we've defined a couple of new link target attributes. So this EXP attribute is essentially a hint that information about this resource should be exported to the DNS or perhaps other sorts of directories. Right now, DNS is the only thing that we're considering. The granularity is fairly coarse in comparison to resources. So for example, if you had a device that was a clock radio, you might export the API entry point for the clock behavior and the API entry point for the radio behavior, but you wouldn't export to DNS all of the individual controls like the on-off switch and all that stuff. The INS target attribute is essentially an instance. It works like an instance name. So it basically uniquely identifies this resource from all of the resources of this given type. RT is not a new thing. I don't know what's listed here, but anyway, one thing we're thinking about is perhaps a federated namespace, so that all the resource types that can be exported don't necessarily need to be listed in detail, but potentially you could list in the registry just the name of the SDO that standardizes the types of resources below it. And I'll get into that in a minute. IF is, again, a semantic tag or a link to an interface description, something like a waddle or perhaps a schema to describe this resource and how it works. Next slide. So here's a very rough summary of what we're talking about doing. As I said, a given resource that wants to be exported to DNSSD would start by having the EXP attribute, and so then these other things would be required. Well, I see. That's why the previous slide said new and/or required link attributes. So the instance attribute would be required if you wish to export this. It becomes the instance part of the service instance name. The resource type becomes the service type. The URI of a given API entry point becomes a part of the text record. Similarly with the interface description, any other attributes would also go into the text record. So the idea here that's maybe a little bit different from previous DNSSD patterns is that what we would like to do, I believe, is to export multiple text records per SRV. So we're basically talking about multiple APIs that live at port 443, let's say. There actually is support for that in the DNSSD draft, but I don't think it's used very often. Next slide. So here's an example. I don't have a pointer I can wave around, so I've color coded these a little bit. You might start off with a query. There might be a mapping agent that does this mapping from resource directory entries into DNSSD entries. And so it starts by basically doing a discovery of all of the resources that have the EXP attribute. It gets back, for example, something from this node at FDFD1234. It says I've got a sensor. Here's the URI to it in red. The content type is 5.0, which basically is JSON. The resource type is oic.r.temperature. In this case, OIC would be used as the main type of this resource, and our temperature might be the subtype. The instance is indoor temperature. The interface, in this case, oic.if.s, refers to a schema that you can use to basically look up and see how this thing is operated. And the resulting resource records are below. TBD is how to generate a quad A record if it doesn't exist and what domain we should map this thing into. But essentially, we would create a pointer record listing a new OIC type. We would have the instance name of indoor temp, which came from the original record, and then we'd have a subtype that lists this thing as a temperature sensor. Shoot.
Okay. Got a question in the room, Kerry?
Hi, Kerry. This is Dave Taylor. I have a question on the slide here. In the label before underscore UDP, you have underscore OIC. And the question is, how do you derive that from the information in the core query? Or is this something you'd expect to be some hard-coded table or whatever? Because I can't tell whether you're assuming that there's actually some structure inside the RT value, which you're not supposed to assume, even though there is a convention, or how you would derive that underscore OIC. Where does that come from in the resulting RR?
This is not a well-formed idea, but the idea, I think, is to try to come up with some sort of technique where we could have a federated namespace. And I don't know if there's broad support for this. Again, we're sort of resocializing all of this from scratch. I think if we were to go with some sort of federated name scheme, it would relieve us from having to specify every single resource type that could be exported in an IANA directory somewhere. Maybe, again, that's not very onerous. I don't know how people feel about that. But I'm assuming that there is structure in the resource type string, and the OIC is the first label, and then everything under that is essentially the domain of that SDO. Again, I just sort of picked OIC out of the air. I don't. I'm not trying to imply that. Okay.
So I don't know why you need that. I don't think we should assume that there's any structure in the RT value. But it occurs to me that I don't know why you need that. If, for example, if you just put in some label that means that it was derived from a core query, why do you care which SDO it was? Right. All your RT values are unique. Isn't that simpler? What's the use case you'd want that for? And why can't they just be a constant?
Hi, Ted.
So a couple more questions. I think the queue is forming here for you, Kerry.
Obviously, this is a popular idea. This is Ted Lemon. I'm not saying that what I'm about to suggest is correct. I'm just curious as to whether or not you considered this as a possibility and already discarded it. If I were just naively thinking about how to get core and DNSSD together, the way that I would think about doing it would be to say, oh, core is a service. And so DNSSD, you just offer core as a service in DNSSD. And then all of this complexity goes away because you're just saying you can do core with this device. And then what you do with the device using core is up to the core implementation.
I hadn't specifically thought of
Does that make sense, or is that
I think
not
the key
what we
takeaway here is that we would like more interaction between the DNSSD working group and the core working group. So those of you who sort of have a foot in each camp, it'd be great if we could come forward with more use cases and more specifically operational and implementation experience. I should say that there is an RD interop plan for mid-April, and so that's maybe the first opportunity to try out some of these ideas. I think it's going to be virtual. I think it's going to be an online interop.
Kerry, where is that interop happening? Okay.
Christian Amsus, I think I can answer that question because I will be holding that interop. Yes, it will be virtual, and right now it is not planned in a very precise way. So we are still waiting for potential participants to input us with basically what they have implemented, what they would be willing to try.
So I didn't catch a name there.
I could back up.
Christian Amsus on the RD DNSSD tool of
and that is that when this work was originally conceived, it was in the context of a protocol that was being developed that was heterogeneous, where we potentially had HTTP clients operating through cross proxy. Because of the rough equivalence between REST in HTTP and REST in core or in CoAP, this cross proxy is potentially easier to implement than an application layer gateway. So just to advertise something as being core capable or CoAP capable might not actually help out an HTTP client. So they might actually want to get to to the links and manipulate them through HTTPS, if that makes sense. Okay.
I'm hearing several comments around a common theme here. I think you're right that we could help with more communication between this group and the core group. Dave made a good comment about how you do this translation, whether it's a mechanical translation or whether there's a big table somewhere that lists the translations. I think that is that's maybe the key challenge. The introduction to the roadmap document talks about that, because I've realized that regardless of multicast DNS or DNS service discovery or what protocol you use, if you don't have a common vocabulary for describing services, then you end up with this big translation table that this mechanism is using one namespace for listing services, and then another mechanism is using a completely different namespace to describe the same things. I don't know how we solve that easily, but I think that's the issue. I like Dave's suggestion that maybe you lump all core protocol, or CoAP, I should say, I think is the right term. All CoAP implementations are under _CoAP._UDP, but then you can use subtypes that are mechanically derived from the RT to let you do more selective discovery of, so you're not discovering every CoAP device there is, but just the ones you're interested in. I had one little nit on this slide. At the bottom, you have 3 separate text
Yes, correct.
records. I think what you probably meant there was one text record with 3 strings in it. So, okay, just a minor detail.
Christian Amses, I'd like to add one point to the discussion of whether we should have some part of what is derived from the RT in the type. One use that we were considering is that there might be a group of resource types for which it makes sense to use an HTTP proxy that is actually advertised through the resource directory, or that is known to the REST environment to be an equivalent resource. Advertise that via DNSSD, so that a client that only knows HTTP knows DNSSD and knows how, for example, say _OIC services work, could use that reference without even knowing that there is core involved.
Hi, Barbara.
I know I'm not wearing my badge, but you know me. I'm Barbara Stark. Hi, Carrie. You know me too. So, and you know the work that's been going on in Broadband Forum on USP, and we've got a protocol that's running over CoAP, and it does DNSSD, and it does nothing like this. How would you expect something like that has a completely different DNSSD scheme to work into this sort of thing? Or is this more of what we need to discuss?
So, if you could bring me up to speed on that, or send me a link, that'd be great. Thank you.
Yep, no problem.
Nope, that's it. Thank you.
Okay, there's no one else at the mic, Kerry. Is there more slides here, or was that the last slide? Okay. So there's clearly interest in this topic, and I think we did mention earlier coming up with a rechartering, so maybe factoring in this type of interop and interactivity, whatever the word is, it would be a good thing to put into the charter. I think it would be good if Christian, are you on the DNSSD list, Christian? Could you send a list, info about the interop to the list?
Can do.
If you're not on the list, feel free to send it to the chairs and we'll advertise it. I think this is something we need to pick up and have some people involved with, and something like that interop event sounds like a good way of getting some communication going. So thanks very much, Kerry. I think that's very useful. I think we need to progress that. So that then takes us on to probably the largest item we've put time aside for, which is discussion of DNSSD privacy. So we have a couple of people that are just going to speak briefly to that to prime the discussion. Is Christian here? Yes, sorry. And Stuart. So basically what we would like to do is to discuss the scope and requirements of privacy within the working group so that we can agree what work we want to do. And it may be that we continue to progress with the work that Daniel and Christian have done so far, which I think seems to be the working group consensus that it's good work. The question is it the right work? Is it the complete thing we want to do? How does it fit in with the broader view of privacy that we have? So we have a couple of people who are going to just talk to this topic first, and then we've got essentially the rest of the session to discuss the topic. So I think Christian's going first, if I remember rightly. Oh, it's just Christian talking, is it? So, but I've got two slide decks. I've got the scaling talk and I've got the scenarios. Scenarios first, cool. So, you've got to stand in the box.
Okay. And a clicker.
Good morning. I am Christian Wittemer. I've been working on DNSSD privacy for some time. And I'm very happy that after 2 years of working on that, we start getting some feedback. Okay. So the first feedback was that we need to have consensus on what scenarios we are addressing. And so we had a couple of hallways discussions, and I'm trying to summarize this with the scenario that we are seeing. So the first scenario, I mean, the kind of threat we are looking at, all those threats are linked to roaming users. I mean, it's pretty clear that if you do a discovery scenario in your own house between devices that stay within the house and nobody listens to them, the privacy considerations are pretty minimal. But what happens is if you move to a public place, then you have an issue is that if you use DNSSD today, or in fact any discovery protocol, it's not specific to DNSSD, replacements have the same issue. You will send metadata with your queries, and that metadata can be used by adversaries like the guy in a hat in this slide to collect information. For example, if we use DNSSD in a coffee shop to discover the printer in the coffee shop, well, obviously, that there is a printer in the coffee shop is not something that is secret, and discovering it is not a big privacy issue. It's meant to be discovered. But having someone register who is using that printer when, and specifically who is in the coffee shop when, because of metadata leaked by the discovery, that would be bad. So in that scenario, a scenario in which the server is public, the client is not, and our goal there is to not disclose the client identity to make sure it can not be linked. You have a second scenario. Suppose that David and Stuart are in a coffee shop and they are deciding to do some application. So they use DNSSD to synchronize their application. One of them becomes the server, the other one becomes the client. They discover each other, they do some fancy application, and life is good. Except that the guy in the hat has looked at all the metadata, and now he knows that David is speaking to Stuart. So he knows that both of them are here. And he also may well know what kind of service they are using and infer what kind of job they are doing. So in that kind of scenario, our requirement is clear. I mean, we would like to make sure that nothing is public, that we don't disclose the client identity, and if possible, that we don't disclose, we don't disclose either the client or the server identity, and we don't disclose the type of service that they are doing. So that's, I think, is the classic scenario. In the preparation for this meeting, we discussed these two scenarios. I added another one. I think that David is a pretty modern guy, so he has a fancy watch, he has a fancy phone, and the fancy watch is trying to discover the fancy phone using DNSSD to see, hey, should I update my screen or something? And that's pretty much the same scenario as the one we have seen before, okay? Because, I mean, this DNSSD scenario will leak information, and we would rather not have it disclosed. Yes, sir.
I'm glad you're including all these scenarios. You said this is pretty much the same. It mostly is. There is one difference, though, which is that in this scenario, David's watch and David's phone are both owned by David.
Yes.
So there's, in a sense, a bubble that those devices talk to each other, but they don't talk to other things.
Yes.
In scenario 2, David could be exchanging copies of the slides for this meeting with me, with you, with Tim.
Yes.
So you can't assume that those devices were set up by the same owner at home in preparation for this meeting in the coffee shop.
yeah, you're correct. It's the same requirement, but it is not the same scenario. And that's pretty much the scenario that we are concerned with. Okay. The next point that I wanted to say is that if you look at the general class of solutions for those problems, they all involve having some kind of secret shared by the client and the server and used to protect the discovery mechanism. I mean, how you do that exactly will vary, of course, greatly depending on the specific protocol you choose. But I mean, this requirement that there be some kind of secret shared is pretty much inherent to the scenario. Now, the problem there is that we have two ways to think about those secrets. And in many implementations, like when you are doing your pairing of your Bluetooth device with your car or something like that, we are using one single secret exchange to do both the authorization of the service and the protection of the discovery. And that's the classic pairing scenario. That's not necessarily the only scenario. I mean, in fact, if you look at the discovery requirement, it may well be adequate to have a lightweight discovery filter, which is just meant to ensure that the message that we are exchanging don't leak metadata, and to have a distinct authorization procedure, which is meant to ensure that the client is authorized to access the resource that the server wants to make available. So that's just to say that we don't necessarily have to tie together those two authorization models. And in particular, it may well be that in a number of implementation, the authorization model is dictated by the application and may or may not be the same that you use for the discovery. And that's it for the introduction. I mean, any question about this introduction? Okay. So,
should we answer some of the questions we had, or should we do that after Christian's second set of slides? Do that so Christian can sit down.
Yeah, well, I guess Christian can just do his and then he can sit down after.
Yeah.
Yeah. Okay, so Christian's also got, excuse me, I've got a Fox's. Christian's also got a little deck on the scaling issue, so Christian can just run through that, then he can sit down while we start the more fuller discussion.
Can you go in load slide mode?
Yeah. There we go.
Okay. Okay. So I suppose that you were all in Singapore when Stuart presented his misgivings about some of the current developments. I was not, I could not travel there, but basically, if we see, we got feedback eventually at IETF 100, and there's a lot of feedback, but I've tried to put that in the big bullet points, okay? There's a first level of feedback, which is relevance. And relevance in the sense that we have discussed that in the DNSSD working group, discussed privacy, but we got actually very little feedback in the working group, as if there was only minimal interest. People were polite, but one of the reasons for that may well be that most of the discovery is not done with the spec of the working group, but is done by integrated spec in a big, say, IoT stacks or whatever. I don't know about that. I mean, if that's true, I mean, I'd like to hear. The second specific piece of feedback on the solution that we proposed focused on 3 points. One was that in our solution, we proposed a per device model, which is in line with many, I would say, historic implementation of DNSSD, but which may not be in line with the emerging usage. And the emerging usage is that people install applications and that the device are controlled by the application. I mean, like if I install, and Stuart was giving the extreme example of a medical device that is embedded in your body. Well, you want that to be accessible by the medical application on your phone, not necessarily by the form simulation. So it's clearly something where you have to have application. And yes, you can achieve that by having in the operating system a centralized service, which is then specialized with a lot of access control procedures and things like that. That's clearly one way. But a very simple way is to imagine that you are doing the discovery from within the application itself, so that basically things are well compartmented. And in truth, if you are doing the discovery from the application itself, it does lead to simplifications in the model compared to what we have. Because the per device model forces us to, leads us to have a two-phase implementation in which you first discover a privacy service on the device and then use that privacy service to discover the actual private services. The second class of feedback were details on the pairing process, which basically was, that was the work of Daniel Kaiser, who really took the state of the art in pairing protocol and focused on the solution based on short authentication strings, which has some very good theoretical properties, but which has one weakness, is that it ends by asking the user to compare the pin on the device and the pin on their control phone. And there is a psychology hole there, is that if the user is tired and really wants the dancing to complete, they'll just click OK without looking at the numbers. There are ways around that. It may be that the UI of the pairing, that we keep the short authentication string, and in the UI of pairing, we just ask people to actually copy the number, which would have good properties. Or if you have to copy the number, one other way is to go to a pin-based protocol in which you specify the pin at the beginning and then don't ask questions after that, have everything automated. We could have a long discussion there. I would rather table that discussion for now because it's really specialized, it's details of cryptography. And I will go to the next one. The next one, which was pretty much the biggest objection, is that at a high level, what we specify looks complicated. It looks complicated in terms of scaling in particular. Some of the exchange require a large number of publications or a large number of messages. So I went back a bit to the drawing board and say, okay, do we have a fundamental tension between privacy and scaling? And what are the trade-offs? And that's what I would like to present here. And in order to examine those trade-offs, I looked at three options. The first option is what we have now, which is require a pairing process, which leads to pairwise secrets. The second option will be, the stupidest. It's there for reference. It's not something that I actually want to implement, but to say, what if we just add a secret shared by all the authorized clients? Like, you know the password of the printer, then you can use it. Well, that's not that stupid. That's actually what most coffee shops do to let you access their Wi-Fi. But that's one possible thing. And clearly, because you have something shared by every client, your scaling property are going to be different. And the third design is to have something based on public key and effectively treat that shared secret, use for that shared secret the public key of the server. So let me justify that for a moment. A public key is a unique identifier. So in any public key solution, you're tempted to say, oh, it's a public key, it can be public. But in fact, given the way protocols are done, if you know the public key of a server, you pretty much can track that server. So for public key solution in a privacy environment, you have to assume that the public key of the server has to be kept under some kind of control. And you can do a basic design in which you do a first, I'll do that as a theoretical design. I've not tried to integrate that in DNSSD in any way. But you have a first message, the query message, which is say, hey, I'm looking for this server. And you do that by sending a hash of the key and the nonce. Or if you want to spend more cycles, like an encryption of the nonce with the public key of the server, so that only the server can decode it. And then the reply comes from the server, and the replies includes an encryption of the nonce with the private key of the server that the client can verify to check that, yeah, that's really the server I want to have. That gives you a fairly secure protocol. And I don't know whether people have actually designed protocols like that, but it's a fairly obvious design. And I will now look at the scaling properties of those three options so that we can make informed decisions later. So if I look at that, there are many dimensions of scaling, okay? The first dimension is the number of clients that you have for each server. The other dimension is the number of servers that you have for each client. They're not necessarily the same because there's some kind of a fan out happening there. And a third interesting dimension in terms of network traffic is the number of servers that are present in the scope. So, for example, my phone can be peered to 50 other phones for some game application or whatever, but of those 50 game partners, maybe only 5 are in the room at a given time. So these are the difference between M and P in that scaling property. First, the first operation in discovery is publication. I mean, the server who wants to become available is going to publish something. Like in the DNS mode of DNSSD, the server will push a set of records that says, hey, I'm here. Well, if you want to have pairwise keys, you will have one record per paired device. So it'll be N. If you want to have something which is common to all clients, be it a shared password or a public key, you will have just one. So that's so far, okay? The number of response to a query, if you do DNSSD and you say, hey, how many servers are there that implement service number X? And I'm taking that with the original design that we have, in which the service is specified as the privacy service. Well, in the case of the pairing solution, you will receive N times P responses. Because, well, you have N response per server and you have P servers present. And the client will sort out which of those are good. In the shared secret, you will receive one response from every server, and so in the public key. There is a variation of that we have not implemented in our draft, but could be done. Suppose that instead of making the instance name a function of the nonce, you make the service name a function of the nonce. So basically, servers advertise random services, randomized service, and clients can predict which randomization scheme the server is using. Well, in that case, the clients will receive exactly one answer. And that may be something we want to consider. And that's one answer in every scenario. We could have client mode in which the client just not a wide search, but one query per server. And in that case, basically the number of queries go with the number of servers. Another dimension of scaling there is whether caching is possible. So in MDNS in particular, we do caching by listening to response to other clients and caching them. And if you have a pairwise secret, you cannot do caching because each response is manufactured for exactly one client. In the shared secret kind of stuff, then you can do caching because it'll be the same response to every client. So clearly that gives us some scaling properties which show that having pairwise secret is more expensive, even with optimizations. The next dimension of scaling is not about the day-to-day discovery, but about what happens when things go wrong. Clearly, if you have a shared password with 500 people, as long as nobody leaks it, you're good. And in fact, you're good with pretty much every of those design if you make the hypothesis that all your clients are good, that they will never be compromised, and that nothing bad will happen. Now, if you assume that one client is compromised, you have to do some remediation. And the cost of remediation will vary depending on the scheme. If you have a pairwise secret, you will just need to repair one secret. You will need to say, oh, Stuart, your key is compromised, let's get a new one. But if you have a shared secret, you are going to obviously need to go contact all the clients you had that have that shared secret and tell them, hey, you know what, our global key is compromised, we have to pick a new one, everybody has to change. So that gives you this cost of remediation there. I say the cost of remediation on pairing is on the order of the number of servers that are paired to the client. The cost of remediation on shared secrets is that times the number of clients paired to each of those servers. The consequences of a compromise also differ. Obviously, if you can impersonate the client, you will be able to discover all the servers that that client can discover. And that's true for every solution. Now, the next thing is, can you not just discover the servers, but also the clients that are connected to that server? And if you have a shared secret, like a shared password, the answer is yes, absolutely. If you have pairwise secret or a public key, you can do, it depends on your design, but you can do design in which that property is not true, in which basically you get some good isolation. The next thing is, can I impersonate the peered servers? In the case of the pairing, the answer is a flat no. You cannot impersonate the server because you only know the key for one client. So you won't be able to impersonate the server for the other clients. In the case of the shared secret, yeah. And in the secret public key too, okay? You can say, you can pretend that the server is present. And if you pretend that the server is present, you are going to discover the other guys. Now, in the case of the public key, I may be a bit pessimistic because if you pay the cost of having your query encrypt a secret with the public key of the server, then basically you need to have the private key of the server to decrypt some secrets, so you have a protection too. So effectively, you can say that the pairing and the secret public keys have some similar property there. I feel the cost of remediation is higher in the case of the shared public key because you have to tell everybody that the public key has changed. So if I summarized, in the case of the pairing, we have more messages in the case of the public key, but we can remediate that if we make the secret dependent on the service ID. I mean, basically, if we have if we have the service ID depend on the secret, obfuscated by the secret, in which case we are back to order of one. The pairing is good in compromise resistance. The shared secret is definitely something you should not do because, it fails catastrophically. In the case of the secret public key, it depends. If you are ready to pay the cost of more public key operation, you might be protected. The remediation is easier in the case of the pairwise secrets and harder when you have shared secrets. So that's pretty much the summary. So if you ask me now, yes, Dave, I'll go back to previous.
So, Dave Taylor, I think there's another row that you said verbally, and I want to confirm that I have the other contents right. If the other row is cost of CPU, then pairing and shared secret are basically symmetric and therefore fast by comparison, and shared secret public key is asymmetric and therefore slow by comparison. Is that correct?
That is correct.
Okay, that would be another useful row to say if you're talking about scaling in terms of processing time and power. Yeah.
That is correct. And in fact, that's one of the weaknesses of the secret key is that if you have mechanism in which random people can ask a server to perform a public key operation, then it becomes possible to DOS that server. So yeah, that's true. So if you ask me for my preferences, without constraints, I'll be tempted to go to something like the secret public key class of solution because it has some pretty good properties in terms of effectively in terms of provisioning. If you want to provision a client in the case of with a public key, you just have to give them a copy. If you want to provision a client with a pairwise secret, you have to do something complicated. So that's one thing. The one thing which is not clear with any public key solution is whether it fits in the DNS formats. Like, for example, take the service ID, it's a DNS name port. It's 64 characters at most. And there are not that many public key operations that can fit in 64 characters. Okay. Now, there may be a way around that, like you send additional text record or something like that, but it will require some engineering, okay? So my preference, if we must keep the DNSSD protocol and format, is to keep pretty much the draft that we have and consider two simplifications. One, go for an application-based discovery because it's simpler to implement and ship than the device-based solution. You don't have to change the operating system in particular. And the second one is to consider using a secret-dependent service type, like make the service type a hash of the secret and the nonce so that you get exactly one answer to a given query, which goes for fewer messages, and that's better. But that's just my opinion. I'm waiting for feedback.
So thank you very much, Christian. I think this did a really good job of showing the various possibilities we have. And so I'd like to kind of kick off a discussion in the working group where our goal for today would mainly be to figure out requirements, as in the use cases that Christian described earlier. Are those the ones we want to solve? Are there other ones we want to solve? Are there ones that we specifically don't want to solve? Because at the end of the day, there are quite a few compromises here. There are quite a few options. For example, if we want to do symmetric or asymmetric crypto. And based on what security properties we want our system to have, some of these will work and some of these won't. So if people have questions or topics they want to bring up, please come ahead now. Otherwise, I'll start with a few questions, get people's opinion.
Yeah, Chris Wood, just a quick clarifying question. Chris Wood. What kind of constraints are we setting for the type of cryptography using? Christian discussed just basic symmetric key stuff and then standard public key stuff, but there's more, there's newer flavors of cryptography that could be applicable here. In particular, some work that Dan Bonnet and others did from Stanford on this exact problem, private service discovery, and they use fancy identity or pairing-based cryptography, and maybe we should or should not look at that. It's not at all been discussed in the IETF, but the properties that it provides are quite nice. In particular, it gives you stronger identity hiding when you're advertising or placing service records somewhere, and when a sender or client wants to contact the service when it sends its initial whatever request, I don't know what the right terminology would be, that's completely hidden and they have full deniability of actually doing so. So I would like to lobby for including these newer types of primitives, and of course maybe consulting with the security area or the CFRG to see if that's something we can start looking at, because there's certainly room for improvement.
Yeah. So please do send a pointer to that for the list. I don't think David or I are familiar with that work, so probably the group isn't. So,
yeah, certainly. I have a pull request on Stuart's draft, in which there's a pointer to the document. So, but I can also circulate to the list as well.
Okay. All right. Thanks.
Yes, like Tim said, I'm not personally familiar with these, but I think it's definitely something we should consider. So if you can send us some background and have a few people here kind of look at it and see, that could definitely be of interest. Thanks.
Chris, you asked a question generally of the room. My opinion is we should not be ruling anything out in principle. We should look at it. We may decide later about what's appropriate or not appropriate or easy to implement, but definitely we should not rule anything out before we've looked at it. As David said, I was not aware of Dan Bonnet's work. I will add that reference you sent me, and I can update the draft. I think this is a relatively new area. A few years ago, nobody really thought about privacy in these cases, and I think that's why this is a new field, and people are still coming up with ideas. And I certainly don't know all the crypto, but that's partly why I wrote that requirements document, which asks a bunch of questions without really giving answers, because I don't claim to know what the answers are yet, but I'm hoping we'll find them being developed.
Actually, unless you're directly replying to Stuart, Kerry's in the virtual line. So Chris, is this a reply to Stuart or something slightly?
Go ahead.
Hi, Christian. Thanks for this work.
Tim, you want to press
I think
the
I'm trying to understand at the end of the day exactly what sort of metadata is being exposed by the roaming client. It seems to me that we cannot cloak the IP of the client or the IP of the responder or the fact that the client is doing discovery in the first place based on, perhaps the port that it's accessing. So I guess at the end of the day, is this work really about cloaking what the client is trying to discover and what it's getting back in response? That's number one. Number two, it seems to me that, obviously one privacy problem with clients is that they should not be advertising any services without the knowledge of the user in the clear. So those are maybe two separate problems that have to be addressed in this work.
Thanks, Kerry. Yes, if you look at the original draft that we do, the DNSSD privacy, we listed the set of metadata that are in the DNSSD headers. And you have things like a service name in the clear, service instance name in the clear, and host name in the clear. And these are independent of the IP addresses. In the case of the coffee shop scenario, you don't care that much about your IP address. You just got it from the coffee shop. So it doesn't matter. It's not something new. You may have other information like your MAC address and things like that, but I assume that somebody else is taking care of that. So really what I'm trying to protect there is the metadata that is specifically generated by the DNSSD protocol.
Chris Wood, a quick kind of clarifying, maybe process-related question, I guess sort of related to what Stuart was saying. Is there, or what are the plans for collaborating with the security area on this particular problem? Because they will, of course, have very strong opinions about which type of crypto we use or which type of security design we have, and better to start that earlier rather than later.
Yes, I believe we have had a security area review of Christian's pairing draft, but that was just looking at the specific thing we put before them. It wasn't a broad question of what would you recommend here. It was an evaluation of the approach that Christian and Daniel had taken, I think.
Yeah, we had an evaluation both of the privacy of the discovery and the pairing, and they say, well, yeah, okay, basically the high level thing of the privacy discovery is that we are using obfuscated discovery to find a service, a private service, and then doing a TLS connection to that service. Right. So basically we're using known components, and if you're using known components, you're pretty much in the clear.
Sure. I was mainly asking if we're going to not rule anything out, there will be new things that have not gone through the security review process. So certainly we want to get that pipeline well defined so we can start working with them.
No, absolutely. And we definitely plan on asking for their feedback, and especially if the new crypto pixie dust that you mentioned, if it hasn't been reviewed by CFRG yet, we'll need that, of course.
So Dave Taylor, follow up on a couple of the comments. Let me start by following up on the comment about what's old and what's new. There's a related field that's old because this is only solving half of the problem. Okay, so what's old is if I've already discovered you and I want to open up an authenticated channel with you, how do you do that in a way that preserves privacy, right? And so in Christian's first use case, where one side is public and the other side is private, that's the typical case that everybody does in authentication today, and one side is private, okay? The other cases where both sides want to be private from intermediaries and not reveal their identity is a case that is a field that has been around for at least 15 years. It originally started as being called the secret handshake protocols. And now the new term, as of maybe 8 years ago or whatever, is renamed as affiliation hiding authentication. So AHA, if you search for affiliation hiding authentication, you'll find stuff. I actually gave a talk at the core working group a couple times ago where I had a whole slide of a bunch of sort of one bullet references of things in that area. Okay, and so I also sent emails to the CFRG saying, this is well known in the literature to have affiliation hiding authentication, but there's nothing in any standard or in any widely available implementation. But in the research, it's been around for 8 to 10 years. Can we do something in the standard so we could actually use this with protocols like TLS? So far, nothing's happened yet. Okay, and the point is, what's new is to say, well, this problem that says I only want to discover things for which authentication would have succeeded. That's the new part of the problem. And what Christian and people are trying to address now is how do I discover things for which the authentication using one of those mechanisms or that style of scenario would have succeeded. And I want to discover things that would not have it succeeded, right? And I want to do that without revealing the other metadata that Christian mentioned, right? That's the part that is relatively new, okay? But the discovery is only half of the problem. I have to be able to open up an authenticated session with, TLS or whatever else it is. And if the same scenario is you're just going to reveal your identity anyway, it's only half the problem, okay? And so we actually need work from CFRG and other people for the other parts of the problem, okay? And so how do we relate to the rest of SAG and so on? Yeah, we need some work and standards and so on to make sure that, say, typical TLS libraries and protocols have affiliation hiding authentication schemes that preserves the identity of both sides, right? Today, usually one side reveals its identity to the other one and they establish a session, right? That's what's standardized and widely used today. So I don't know if you have a follow-up on that, but that was what I talked about, and I have a whole slide of different links of a survey in the field if you're interested, and I can point that to the list. So.
Yes, definitely interested. The pointer to the list would be great. Thanks.
Chris Wood, yeah, just going back to the work of Monet, they do, in fact, their solution does provide mutual privacy for both the sender and for the client and the server by exploiting the fact that there is a private discovery step beforehand, so that these two kind of problems are very tightly coupled. If you do just try to connect to a server and then authenticate, of course, any active app adversary can learn the identity of at least one of the peers, but because you're doing this discovery beforehand, they're able to work around it. So it's interesting that two work together like that, and I'll just point to the paper soon. So
yeah, we are somewhat in approaches discussion there rather than the scope and requirements, I think, still. So maybe try and these are all good points, but maybe just step back a bit to answer some of the questions in Christian's deck. And David and I have just thrown some more questions on the screen there, for example.
The additional question is, and that's pretty much what Dave Taylor said, is should we be concerned with the privacy property of the actual connection between client and server? And that's a piece of work. My take is that piece of work is probably something which is more on the TLS working group than the DNSSD working group. And that's why I did not want to take it here.
Yeah, that makes sense.
One way I would rephrase that is as a requirement. Do we have a requirement that private discovery allows us to bootstrap an authenticated encrypted channel? So one example of that, does it lead to a shared secret or public keys that we can use for TLS? That might be a reasonable requirement.
Yeah, if you look at the draft, the DNSSD privacy draft, the two-phase draft, the second phase is a TLS connection. And when we specify that, we are very concerned precisely with this kind of TLS leakage, specifically the replay attack. I mean, if someone replays your client's connection attempt and the server does a handshake, in TLS, the server's handshake reveals the server's identity. So that's why we add basically a shared secret, a PSK in the original client hello that will protect the handshake and allows the server to not do that. Now, whether we want to have that class of solution generalized to other application, that's indeed something we can debate. But we may want to respond to those four questions first.
Okay, so on the first one, I think kind of the meta question is, we're building a lot of new infrastructure in DNSSD that can work over unicast and many things. And should we constrain ourselves to have any private discovery need to work with that? Does anyone in the room have an opinion on this topic?
The way I read your points are not questions we're necessarily going to answer right now, or maybe not even soon, but things to keep in mind. On the first one, my hope is the answer is probably yes, that whatever privacy mechanisms we develop can also be exercised remotely via a proxy. The second one, the answer may be no, because if the privacy solutions that we come up with involve the responding device doing some crypto operations to decide whether to respond, it can't do that when it's asleep. And it may not be willing to hand off its credentials to a potentially questionable sleep proxy that could then masquerade as the sleeping device. That, I think, it may be a question we can't answer. It's a question that we should document, that we say there's a trade-off. If you're building a super low power battery device, then you don't get these privacy benefits. Or if you want the privacy benefits, you probably can't do that with something running on a lithium coin cell because it can't go to sleep. So my suspicion is we won't solve problem number 2, but we need to lay out the trade-offs that you get to pick one or the other, but not both.
Tom Pusateri, seems like in the first case that you are going to limit what you can do if you require that. Christian stuff seems to be, working independently of that, and once you have to reveal something to go through a proxy, and so you're obviously going to reveal more than you would have to if you don't. So I think there's two cases here, and we might be okay to have a subset that works with a proxy, but it won't be the same as what Christian came up with.
Thanks. No, I think that's definitely a possibility where we have a subset of the privacy work that works across it and some that doesn't. I think that's reasonable.
Michael Abrams, so the last point there, what granularity of trust, what kind of trust are we talking about here? What trusts what?
It's whether it's around the user, the device, the application. And that was I believe that was the question.
And by trust, I mean, if I trust you, I allow you to discover me. And then the question is, who's you? Is it you as a person? Is it this chat application? Is it your entire device? And that's what I meant by trust. It's
right.
Who gets to get this privacy sensitive information?
Right, that's a tough question because of sandboxing. Some applications I might not want the entire device. That is an excellent question.
This is Dave Robin. That leads me to my burning question that I've been sitting here waiting for somebody to discuss. When you talk about granularity, going sort of to an application granularity instead of a device granularity, to me, and then trying to hide that application, the problem with that is that application that's trying to hide, the application doing the discovery itself, it's doing it with my MAC address, which I had another application that did this completely plain text thing over here that completely identifies me. So what's the point? You had this super application that's trying to secretly find something, but my traffic is originating from a device that has been clearly identified by other leaky things. So in the case of the blood gas monitor or a printer or a specific function device that has one function and one application, it's easy because that random MAC address that he got that's completely private, but it's associated with that one application, and that's fine. His entire existence is that one application. But when you have a multi-tenant kind of thing, platform, with only one IP address, how do you have any privacy of the apps? To me, that's sort of like each app needs to run in its own little virtual machine with its own bridged MAC address, and it has its own stack. I don't know any other way to do it. How can an app hide without having its own stack, its own IP address that is completely opaque?
So I think I'll attempt to answer that, and I think the people at the mic can add to that. It depends what we mean by hiding. In the example where, let's say, I have a phone that is simultaneously trying to print on the coffee shop network, but also talking to a medical device that I have.
Right.
I would be okay if the printing system leaks my IP address and people know that David's printing, but I would still want to keep hidden the fact that David has this medical device, or that David is running this medical application. And I think even if one leaks, the fact that there is an IP that's sending packets, still trying to hide like the name of services it supports has value.
Okay, I would agree with that. My mind always races ahead to fingerprinting. And so I can obviously tell that you're talking to a blood gas device because of its signature on the network. And so therefore I know, because I've identified you as David, I can tell by your signature of behavior of conversations as to who you're talking to. Otherwise you'd introduce random jitter and all that. I mean, it goes on and on and on, right? To try and hide your behavior and your signature becomes a whole different set of problems. But if you are one device with a virtual MAC address and a virtual stack, and you've completely privatized, yeah, you can tell there's a conversation going on with a medical device, but I can't tell who's doing it. So anyway.
Yeah, we covered a bunch of different topics there. One thing I would say is you raised this hypothetical thing as if it was ridiculous. I don't think it is. I don't think it is out of the question that we could imagine every application having its own MAC address and its own user space stack. Now, that's not the work of this working group, but there is increased. Yeah, Christian, you're saying we're going there. Windows has pretty.
No, it's not Windows.
Windows has pretty good MAC address randomization, which is Christian's work. And I think in the coming decade, we're going to see more and more awareness. There's been new rule changes in the European Union about data privacy for customers. So there's a lot of awareness of this, and I think stuff like that is going to happen. The question of the granularity came to my mind because of a couple of examples, and if I give those, it might make it clearer. But 10 years ago now, Apple launched this service called Back to My Mac, and it had similar privacy concerns that we used to call it the Steve Jobs problem, that when he checks into a hotel in New York with his laptop running Back to My Mac, if it looks up the DNS records for sjobs.members.mac.com in the clear, then the paparazzi can report, hey, Steve Jobs is in New York for some business meeting and staying at this hotel. So even back then, we had some rudimentary idea of not wanting to go around broadcasting your identity. This was before the iPhone existed, and we didn't have portable devices broadcasting our identity. One of the issues with Back to My Mac is it is more or less a per device implementation. Laptop computers can have multiple user accounts. They can have multiple people logged in at the same time. I can be logged in by SSH to a machine that someone else is using, and my Back to My Mac file system and their Back to My Mac file system are all in the same file system. Our kernel doesn't support per user file systems. So you better trust, what it comes down to is you better trust the other people who share your computer, because there is some cross bleed in the Back to My Mac remote file systems. And then the other example that I mentioned and Christian mentioned, just a hypothetical example, but it makes it clear. When my medical app on my phone is talking to my insulin monitor or whatever it is, and I'm playing some free candy game on the iPhone, the people writing the free candy game have no business knowing what my phone is doing. And that really highlights that the simplistic Back to My Mac model from 10 years ago is not adequate for today's world.
Christian Wiedemer. Yeah, I mean, my comment on your question, Dev, is that when I work on privacy, I hear that objection all the time. And the structure of the objection is, why do you bother closing my leak when I can see this leak here? Yeah. Well, and we'll close the other leak too, okay? That's...
So there was a comment on Jabber from Daniel Keisel. Should a medical device really join a public Wi-Fi network for communicating with the phone? But I think here that it is using Wi-Fi, not the public Wi-Fi, right? So it is talking over Wi-Fi, but it's not joining the public Wi-Fi, right? That Stuart can probably say some more about that.
Yeah, hi Daniel, I just ran up to the microphone. The concern we're looking at here is at a lower level than what we might call joining a Wi-Fi network or associating with an access point. If you're transmitting radio signals at all, then other devices in the vicinity can receive those signals. And we want to make sure that even though they can receive them, they can't make sense of what they mean.
Right. Michael Abramson. So I was also thinking, so this is privacy. I probably want to expose what services I'm doing differently to different devices, users, and so on. Is that what we're talking about here as well when it comes to, if I see what my device is broadcasting, it's broadcasting. When I come here, sometimes I see my printer at home being broadcast. Well, why does it do that? It should not probably do that, right? So should it announce different services to different people? If I have set up that I know Stuart well and I'm okay with him printing on my printer and not with someone else, is this part of the privacy discussion or is that a policy discussion?
Well, it's tight.
It is tight, right? So Right. So for me, it needs to be quite granular anyway, because I actually want to share some things with some people, and I don't want others to know anything. So it's policy / privacy discussion, and it needs to be very fine granular. That's my opinion.
And I definitely agree that this is a policy question, and these are the policies that we need to nail down so we can start finding a solution. And I'm sort of getting the sense that the room agrees that we want finer granularity.
Yeah.
So then the finest we have today is probably an application. Am I reading the room correctly? If anyone disagrees, could they share why?
Okay. So yeah, I mean, yes, I mean, I'm kind of convinced that we want to do application. There are also reasons to do application, like portability, like the fact applications can roam from one machine to another and things like that. So it's and yes, I mean, I pretty much agree with Stuart's analysis that we should work through a discovery proxy mostly. I mean, I can't see why we would not. Okay, and that front asleep, yes. Now that scenario, I argue that from the client point of view, is not so much it's not so much a DNSSD scenario as an MDNS scenario, the first one. And basically, it's back to the host name considered harmful RFC. The structure of MDNS has things like I publish my host name and I publish things like that, which tend to be unique identifiers that can be tracked. And there are two levels. If you look at the draft, at the privacy draft, we addressed that by saying that there are really two levels. I mean, there's effectively the MDNS mechanism in which you have, but there are also in the DNSSD publishing mechanism in which you publish a host name when you publish a service. And it's completely under the hood.
So in the example on the screen there, that you produced, that's a printer, and one would imagine the printer isn't secret. People can see it, it's there, you want to discover it. It's kind of, I wouldn't say public, but certainly well advertised within the organization or building. Whereas in this situation where it's a person, that's where you potentially want to natural privacy. And whether each or one or both of those works through a sleeping proxy or a discovery proxy is
questionable. But what I was mentioning is that there are really two levels. There's one level which is the specific problem of MDNS and privacy. And even, I mean, the basics, like you're advertising your host IP address because you need to advertise, you need to have a host name to advertise your IP address so you can link into services. Well, that should be randomized. I mean, you should randomize that so that you don't leak that information. And that's not tied to any of the service discovery mechanism. It's some kind of a low-level thing that we may want to excise and just do. Because it has no influence on the service. That host name never appears on the UI except on the Black Hat's UI.
So right, from a user's point of view, that printer could be called absolutely anything in terms of what the name. It just needs to be discoverable as the printer, a printer offering the service that you want. So we've got a message. We've got 12 minutes left. We need to do a little recap. So we've probably got 5 or 6 minutes for anything else anyone wants to bring up relevant to this discussion in terms of the points we've raised. Is there anything we've missed? So I mean, as it stands, the material we have written in terms of things that are in drafts, there's what's in section 2, I believe, of Christian and Daniel's DNSSD privacy draft. There's Stuart's essentially considerations draft that talks about many of the things we talked about now, and there's the scaling draft. How should we shape capturing these issues going forward? Should we try and bring all this down and distill it into one draft where we describe these requirements, drawing from those three sources. Whether that might all go into Stuart's existing draft, I don't know. Or it could be something fresh. But it sounds like we want to get all these things captured in one place, and we would like, presumably, to encourage a couple of other areas to look at it as well. Probably security and applications would be interested in it. Does that sound reasonable? And if so, would that be into Stuart's draft? Who would be willing to help write this and pull the material together? So I'm guessing Christian and Stuart probably, Chris, so that's good. And a comment.
Yeah, my name is Norman Kowalewski. We have been, I just am late in responding to that queue. Several years ago, there was a EU project called Webinos. That was a cross-domain project and was trying to discover how would kind of all kinds of devices that people will use, including those they're wearing on their body, interact with the rest of the world, with the other things on the body, or with things that other people are carrying on their body. And there was a concept of like a personal domain or personal zone or cloud that's kind of just a kind of a bubble around you. So as if you're running in a balloon, right? And these balloons basically would interact with each other or something like that. And maybe there's a lot of use case work done that immediately.
So that's kind of what's on the screen now, is what you're saying. Is that?
There may be more like that, right? Or there may be a kind of a separation zone around like these individuals that is an entity in itself that's currently not discovered here on these slides. And maybe it's worth looking at that. I can share links to that.
Yes, yeah, please. If you could share links on the mailing list, that would be very helpful.
Yeah, and I am personally a bit concerned with these scenarios because you can think of that as a personal cloud, but you can think of that too as a personal Christmas tree. And so.
So regarding the, go ahead.
I'm sure that the hiding new research, hiding how this synchronizes together with that concept could be worth to look at.
So regarding what might become a requirements document, do so, Christian, Stuart, Chris, do you have a preference on which document that would be? Is Stuart's the simplest? Do you want a new one? What are your thoughts? Yeah, all right, sounds good.
Yeah, we've got 3 bodies of text to draw from there, plus the discussion today. So where it goes, I don't think as chairs we mind, but it's important that the work starts moving forward, or continues to move forward. Okay, so I think with just a few minutes left to go, we'll start drawing to a close. That's been very useful. Thank you, everybody. There was one thing I accidentally skipped over, which was the state of some part drafts, I want another word. I think one of them was the roadmap, which we've obviously discussed and we've agreed here to adopt and we'll take to the list. Another one was the discovery broker, which Ted briefly mentioned, but I don't think we formed any immediate consensus on. What were the other 2? Oh, yes, one of them was the sleep proxy, EDNS. Is that something that's ongoing or okay? So I think we've covered off all of those, so we're good there. The service registration, yeah, and that'll obviously push forward, and the rechartering will help with that. So the things I've got written down here is things we've agreed and maybe some actions. Just wrapping up, the first one was the roadmap documents being agreed in the room, so we'll check that adoption with the list. The next one was the relay, which I think we agreed to adopt as well. I've got one thing written down here. And I think Barbara also offered to have a quick look at that. So it's not a big document, but if anyone else can review that, that would be good as well. The next thing was we agreed it's time the working group had a look at its charter, and we will, I think, through the list, decide what things need to go into the charter and maybe what things come out. So I think there's one of the things there is the new unicast oriented work, what things we need there to support that. The second one, I think, will be, as David said, there's not much in there, if anything, at the moment on privacy, so we need to add that. And I think the third one that we're picking up from Kerry's presentation will be to add something in there about interoperation or collaboration with SD work in other groups to harmonize things as much as we reasonably can. Fifth thing I've got down is there's probably scope for some new document. I don't think we nailed down anyone to specifically work on it. That's probably, I think we can probably guess who it might be. We've got some good guidance on deployment in HomeNet, but the deployment in the campus/enterprise world, some document on guidance on that, and that maybe again comes back to the type of thing that came up in EDUCAUSE as well. That type of document would be good. We've had some earlier work and thoughts on it from Tom and Ralph, so pulling something together there would be good, but we don't have any specific anyone in the frame right now. In terms of the interop with core, we've had indication that there's an interop in April, and details of that will be sent to the list. So I think some participation from this working group in that interop, which I believe is going to be virtual, would be a good thing for the group. And then the last thing, the privacy work, I think we've agreed that we're going to pull together a draft, whether it's building on Stuart's existing one or a new one, to describe the security requirements and to scope that, so we can then get a much clearer view of what we're doing with the future work. So I think that's everything I have. Does that sound right? I'm getting nods from my right. So unless there's any other comments, I think we can close the meeting, and thank you everyone for coming along. And thanks Barbara for taking the minutes, and Michael for jabbering. Thank you everybody.
Thanks. Yeah, if you haven't signed the blue sheets, please come up. Otherwise, see you all in Montreal.
Send that summary to the list. Oh, where's the it's actually one. Okay.
You know, the way I hate issues like this, because this is